We have some actual problems to start with here to see if we understand not just the concept, but how to apply it. Now they're asking us for the difference quotient. You're going to see this phrase. The difference just means subtract and quotient means divide, and sure enough, that's what we see in these problems. So they're just saying evaluate these. It says take this instruction and plug it into these formulas here. That's all that is. So the first one is f of x minus f of a over x minus a. And for us, that's going to be a 1 over x minus 1 over a over x minus a. So how do we accomplish evaluating this? Well, I think the first thing we're going to need is some common denominators. So let's maybe do an ax here. We'll do an a over a and an x over x here. And we're going to get a minus x over ax over x minus a. And when you divide by a divide, you can bring this up into the denominator. So that's going to equal a minus x over ax times x minus a. And that's about as far as you can go with this particular question. But that's what they mean by evaluate the difference quotient. They mean basically put it together and simplify it based on this formula. I'll take that example away since you don't need it. And we'll come to something more interesting like the next one. This one's a little bit harder. They say f of x minus f of 1 divided by x minus 1. And for us, that's going to be f of x, which is x plus 3 over x plus 1, minus f of 1, which we'll just calculate. Let's calculate it. 1 plus 3 is 4. 1 plus 1 is 2, so that'll end up being 2, divided by x minus 1. Okay, so we need to give these a common denominator, so maybe this guy will put an x plus 1 on top and bottom. Plus 1. And we know that that's going to simplify to 2. So we'll just put that on top and we'll get x plus 3 over, this whole thing will be over x plus 1. And it's going to be minus 2 x plus 1. And this whole thing will be divided by x minus 1, which we'll do last. So we can distribute. Here's an x, here's a minus 2x, so we should get a minus x plus 4. 4, there it is, over x plus 1, x minus 1. You see I brought that another divide by up into the denominator? That's the correct way to go. And if you want to get really cute with it, it should be 4 minus x, because starting with a negative number is kind of not cool. So this is going to be the answer for that one. That's all difference quotient is we're plugging in and simplifying the algebra. You can do that. I'm going to do one more here. This x cubed is a good example. F of a plus h minus f of a. Come on, f. There's an f. That's terrible looking. Come on back. F, where's the h? The screen isn't responding, I guess. Minus f of a over h of x cubed. So this is going to be x plus, sorry, that's incorrect. It's not an x, it's an a plus h cubed, so we're taking this input and applying it to the x cubed, minus a cubed divided by h. What do we get? Well, you need to use Pascal's triangle, but you're going to find that it's a cubed plus 3a squared h plus 3ah squared plus h minus a cubed is still there. And we'll do the denominator in a second, but certainly these cancel out. And it's all going to be divided by h, so we'll divide 1h away like this. And this squared goes away, and this h becomes a 1. So I think what we get is 3a squared plus 3ah plus 1. That should be the answer for this one. So what we're coming across here is just basic algebra. You're plugging in the function, you're simplifying it down. That's all a difference quotient is. And of course, this is playing with what we've already discovered is the definition of slope of a curve. We call it the derivative. So we'll get into that later, but just have a quick look at this to make sure that you understand how to plug in function stuff.